do the problem. Prove that 11 raised to n minus 7 raised to n is divisible by 4 for all n element of natural numbers. This is our first problem. How can we do this problem? So first we have to define what is P of n. P of n is a statement regarding n. So it should be a complete statement which has a truth value. So which has a truth value when we give values for n. So here what should be P of n? What you have to prove? It should be written as P of n. So P of n is 11 raised to n minus 7 raised to n is divisible by 4. This is our P of n. Now, what is P of 1? എവിടെയാണോ n ഉള്ളത് അവിടെ നമ്മൾ 1 എന്ന് വാല്യൂ കൊടുക്കണം. So 11 raised to 1 minus 7 power 1 is divisible by 4. Is this true or false? 11 power 1 minus 7 power 1 is 4. 4 is divisible by 4. So this is true. P of 1 is true. Now we let k be a natural number and assume that P of k is true. That means 11 raised to k minus 7 raised to k is divisible by 4. Okay, now we have to prove P of k plus 1 is true. To prove P of k plus 1 is true, we have to prove 11 to the power k plus 1 minus 7 to the power k plus 1 is divisible by 4. So I will write this like this: 11 raised to k plus 1 minus 11 into 11 times 7 raised to k plus 11 times 7 raised to k minus 7 raised to k plus 1. Okay, this is k plus 1. Now in the first two terms 11 is a common factor, so I am taking it outside. 11 times 11 raised to k minus 7 raised to k plus in the second term we have 7 raised to k as a common factor, so you take it outside so that we will get 11 minus 7 here. Now the first term 11 times 11 raised to k minus 7 raised to k, is it divisible by 4? We have assumed here that 11 raised to k minus 7 raised to k is divisible by 4. So this part is divisible by 4. So if something is divisible by 4, if you multiply it with another integer, it is still divisible by 4. So the first term is divisible by 4. What about the second term? So here this is equal to 11 times 11 raised to k minus 7 raised to k plus 7 raised to k times 4. The second term is divisible by 4 because already 4 is a factor here, and the first term is divisible by 4 by since we have assumed that P of k is true. So 11 raised to k minus 7 raised to k is divisible by 4 since P of k is true. Second term itself, this is also divisible by 4. what we get is 11 to the power k plus 1 minus 7 to the power k plus 1 is divisible by 4. That is, p of k plus 1 is true. So, we proved that p of 1 is true. We have assumed p of k plus 1 is true, and we proved p of k plus 1 is true if p of k is true. So, by principle of mathematical induction, we can say that p of n is true for all n element of natural numbers. That means 11 power n minus 7 power n is divisible by 4 for all n element of natural numbers. This is how we are using principle of mathematical induction. Now I will take one more problem. Second problem. Prove that 2 power n is greater than 2n plus 1 for all n greater than or equal to 3. So here we will use principle of mathematical induction second version. Here also we have to define what is p of n. P of n says that 2 power n is greater than 2n plus 1. Now there is no need to check whether p of 1 is true or p of 2 is true. Let's start with 3. What about p of 3? P of 3 says that 2 power 3 is greater than 2 times 3 plus 1. 2 power 3 is 8. This is 7. 8 is greater than 7. This is true. So, P of 3 is true. Okay. Now, let k be an element of n minus 1, 2. That means k is a natural number which is greater than or equal to 3. Assume P of k is true. We have to prove P of k plus 1 is true. So, to prove P of k plus 1 is true, let's check what about 2 power k plus 1. Here assume P of k is true. P of k is true means 2 power k is greater than 2k plus 1. So, 2 power k plus 1 can be written as 2 times 2 power k. And 2 power k is greater than 2k plus 1. So, this is greater than 2 times 2k plus 1. Okay. And this is equal to, this is 4k plus 2. Okay. I am taking, I am writing this as 2 times k plus 1. What is 2 times k plus 1? 2k plus 2 plus 2k. 4k plus, I am writing 4k as 2k plus 2k. Okay, so I can write 4k plus 2 as 2 times k plus 1 plus 2k. So what I have to prove is 2 power k plus 1 is greater than 2 times k plus 1 plus 1. So now I have 2 power k plus 1 is greater than 2 times k plus 1 plus 2k. This is what we have now, and this is what we have to prove. So this 2 times k plus 1 is here. instead of 2k we should have 1 here. So we know that k is greater than or equal to 3. Certainly 2k will be greater than or equal to 3, and it is greater than or equal to 1. If something is greater than or equal to 3, it is certainly strictly greater than 1. Okay, so I can write this is greater than 2 times k plus 1 plus 1. Okay, because 2k is greater than 1. This means p of k plus 1 is true. So what all things we have proved? We have proved p of 3 is true. We assumed p of k is true, and we proved p of k plus 1 is true. Therefore, by mathematical induction second version, we can say that p of n is true for all n greater than or equal to 3. That means 2 power n is greater than or equal to 2n plus 1 for all n greater than or equal to 3. Okay, this is how we are using mathematical induction to prove statements regarding natural numbers. So there are a lot of practice problems in the text, and in the notes I have given. You should do all the problems, then only you will be more familiar to the concept of mathematical induction. So study well. All the best.